This is a custom-designed hexacopter UAV made to carry a toy airsoft gun mounted on a 3-axis gimbal to completely isolate the aiming and firing of the gun from the movement of the airframe. A laser cutter and 3D printer were used to manufacture components, as well as more traditional machining techniques for the aluminum parts. The vehicle's all-up weight is 3 kilograms, and the 6 175-watt motors can each produce almost a kilogram of thrust, for a lift-to-weight ratio of 2:1. The airsoft gun was heavily modified with custom electronics and can be triggered from a remote to provide several hundred rounds per minute. 2 operators are required, one to pilot the vehicle and one to operate the turret. Each pilot has a separate live video feed from the vehicle. The following pictures are of pieces of the build process. This large of a project quickly took over my desk. Organizing and containing all of the wiring was a significant challenge. There is a camera mounted just above the barrel of the gun, and this is the live video perspective that is transmitted back to the gunner. I also designed a computer vision targeting aid that helped control the gimbal and aim the gun. The computer vision camera is shown near the bottom of the frame, and it tracks objects based on HSV color value. The third camera on board is an old GoPro shown in the middle of the frame that simultaneously records HD video and provides live video feed for the pilot. The following clip shows the first functional mode for the gimbal. The gimbal can be set to follow the movement of the aircraft, so when the vehicle yaws, the gun smoothly follows this input. In theory, this would allow the vehicle to be operated completely by one person. The second functional mode for the gimbal is completely decoupled from the UAV. This means that no matter how the vehicle moves, the gimbal compensates to keep the gun in the same attitude and heading. This means that the gun has an extremely stable platform to fire from, which makes aiming at targets easy for the gunner, regardless of how the pilot is flying the UAV. The gunner ground station consists of a helmet with a 5.8 GHz analog video receiver and a small screen displaying the live video feed from the perspective of just above the barrel of the gun. The gunner's controller is a 6-channel transmitter that controls the pan and tilt of the gun as demonstrated, as well as several other functions shown in subsequent clips. 2 of these functions are arming and firing the airsoft gun. The arming switch is a safety mechanism with a visual indicator. When the weapon is armed, it brings up the targeting reticle and remaining ammo count. To demonstrate the safety mechanism, when the arming switch is off, nothing happens when the firing switch is pulled. After the arming switch is flipped on, the gun will fire when the firing switch is pulled. Notice in the upper left-hand corner, the ammo count decreases as the gun fires. The computer vision camera has been programmed to target the red glove in this clip. The human input is fused with the computer target control, which can be scaled from the gunner controller. Here the computer is given the maximum control to auto-track targets as fast as possible. Now the computer is scaled back to 50%, so targets are tracked slower by the computer, but the human input would be given relatively more weight. Finally, the computer can be completely disabled to give the human complete control if they need to swivel the turret to a new target. After months of writing code, designing and manufacturing parts, testing subsystems, and getting everything integrated, I was finally ready for a maiden hover test. The landing gear folds up out of the way to give the gun a 360-degree range without obstruction. My initial PID values were decent, but the D term was a little too high, causing high-frequency vibration in response to prop vibration. For a firing run, I set some brightly colored targets on top of my house for aerial target practice. This HD recording shows the setup from the pilot's perspective on the UAV. This clip shows a recording of the live video feed from the pilot's perspective. Telemetry feedback overlaid on the video includes speed, altitude, distance to home, battery voltage, current draw, and energy consumed. This shows a recording of the live video from the gunner's perspective. The gunner had complete manual control with no computer assistance, and it was reportedly difficult to stay centered on the target. This clip is the same perspective, but the computer was given complete control with no human input. The computer acquires the target now and locks on, tracking much better than the human gunner, even as the UAV strafes and changes altitude. This clip shows the perspective from one of the targets. The clip overlaid in the top left is from the pilot's perspective. The next segment is another HD recording from the pilot's perspective. If you look closely at the bottom of the screen, the small yellow plastic pellets look like tracers flying toward the target. This final clip shows my ground station setup. My wife in the green chair was kind enough to perform gunner duties while I piloted. The kid in the tie-dyed shirt was a neighbor who was justifiably curious about the flying vehicle firing pellets.